Good morning to you, class. On Friday, May the 8th, in the year of 2020. All right. Recording, everybody's on. Unmute yourselves and say something so I can hear something on the other end.
Good morning. Good morning.
Good morning.
So I sent you an email with your with an Excel attachment to it that had your score for the test, your score for the class, and then your updated score for the class with your lowest test score dropped. So that's the score that you go into the final with. The best indicator of where you are is the score with the lowest test score dropped, because we're going to drop that and replace it with the percentage on your final. Remember that our final is 8 o'clock on finals week. So that'd be what, 8 o'clock on the 18th? Do I have that number right? Yes, I do. And next week we'll be reviewing for your final. Got a little bit to finish up on Monday. It won't take us that long. And then we'll roll into review for the final. So you'll want to make sure you hunt up your old test and have them with you for class on those days. We're going to look at problems off of our old test to help us to get ready for the final. And I'm going to give you some problems to work off of those old tests as well. So those problems will serve as just like a review assignment for any test. As far as the test went on Wednesday, on this test, there's usually the great divide. You know, a lot of times I get really high scores and I get really low scores. We saw some of that in our class. Overall, I thought the scores were pretty good. We didn't have any scores in the 90s, but we had several in the 80s. And I curved your test 5 points before I put them in the grade book. So for example, if your score said 80, then I actually put 85 in the grade book. I don't normally do that, but I did this time. So by the time I curved 5 points, then I had 1, 2, 3, 4. We had 4 people in the 90s, which is really good. So we had some homework from last Friday that I haven't taken any questions yet on, from chapter 12, section 1. And we'll take questions on that on Monday, as well as what we're going to cover today. Also, you should have received some information. I sent out an email concerning this as well, pertaining to your course grade options. You can either take a letter grade for the course, you can withdraw from the course, or you can take a pass-fail option from the course. So I put a survey on Moodle about which of those you want to do. So I need you to go on to Moodle and take that survey. It'll take you all of 10 seconds. All you got to do is type your name in and punch which of those 3 you want, and it'll tell me. So hey, before you decide to take a withdraw or a pass-fail, make sure you talk to a counselor at the college. If you're not sure how to get a hold of one of those, just call the front desk, 634-3200, and ask for a counselor. Because in some situations, you may not want to take a pass-fail. Sometimes it has some effect on scholarships. It may have some effect on transferring. So make sure you talk through it with a counselor before you decide to do one of those. So anyway, most of you will probably want to take the letter grade option, but there may be some instances in the class where it would make sense to do a pass-fail. And I'd like to have that information by May the 14th. Technically, I don't have to have it till May the 15th, but when you put things off to the last minute, then you leave yourself open to things that you don't expect to happen, like something crashes with the program, or your computer's not working, or you get sick or whatever. So the 14th will be better, really, for me, and maybe for you too. Well, all right. It says here on our calendar that we want to look at chapter 12, section 2 today, and 13:1 on Monday. So we've already done one section from chapter 12. So this chapter 12 and 13 stuff, we won't have a separate test for, but it will be on your final. So you'll be responsible for. So any homework I've assigned from 12:1, any homework I assigned from 12:2, any homework I assigned from 13:1, know that you could see that on your final. So the homework problems serve as your review problems for 12 and 13. That's what that amounts to. Okay, so today we want to look at chapter 12, section 2. If you look at the title of that section, it's titled Test for Independence and Homogeneity of Proportions. Don't worry so much about the last part of that title. Let's focus in on the first part, Test for Independence. So we talked about independence to some length in our class. Independent variables means the occurrence of one has no effect on the occurrence of another, or the occurrence of one has no effect on the probability of the occurrence of another. So this is a way to test to see if two variables are independent or not. That's what this test is about. It's another type of chi-squared test. So we're going to be using the chi-squared distribution again. So we're going to start, and Michael Sullivan's going to say what I just said. He'll probably say it better than I just said it on page 600 here. It says the chi-squared test for independence is used to determine whether there's an association between a row variable and a column variable in a contingency table constructed from sample data. What does that mean? It means we're going to put our data in a table, okay? And we're going to relate together two variables, like I might relate together age and blood pressure, and see if those two variables are independent or not. So I might have like 20s, 30s, 40s, 50s across the top of my table. Those would be column variables. And I might have blood pressures down the side creating the rows, like 140, 150, 160, 170. Okay. So that'd be a row variable. So that's how we would test to see if those are independent, or if there's a relationship between them, dependent. The null hypothesis is that the variables are not associated. In other words, they're independent. The alternative hypothesis is that the variables are associated or dependent. Okay, now let's grab some paper here and talk through the actual test then. So we are going to label this test the chi-square test for independence. Okay. And here's going to be our 5 steps for the chi-squared test for independence. They just told us H0 and H1. They just said that the null hypothesis is that the variables are independent. So H0, variables, independent. So H1 would be that they are not independent. So the variables are dependent. Okay, so that might make you wonder, is this a left tail or a right tail or a two-tailed test? And by the way, all chi-squared tests for independence are right tail. So in that sense, it's like the chi-squared goodness of fit test that we talked about a week or so ago. Okay, then, so that's step one, H0 and H1. Step two is alpha, which they'll give us. If we were doing our own test, we'd have to set that ourselves. The test variable uses the same formula that we saw on our chi-squared goodness of fit test. It goes like this: the summation of O sub I minus E sub I squared over E sub I. So once again, we're going to have observed variables, observed values, I should say. That'll come from our actual data. And then we're going to have some expected values. Those expected values are going to be the values that we would have expected to have gotten if the variables were independent. I'll have to show you how to calculate those. Okay, and then step 4, we'll do classical or p-value. In step 5, we'll either reject H0 or do not reject H0. So we're going to show you the old-fashioned way first, and then we'll do this on our calculator, and that'll shorten it up quite a bit for us. Okay, well, the next thing I want to show you before we actually dig into one of these tests is a formula for finding these expected values. Your book calls this the expected frequency. And it gives us a formula. And sometimes I talk you through where this formula comes from. I think today I'm just going to give you the formula, okay? But there's a good discussion about why this formula is what it is in your textbook if you're interested in that. But to find the expected frequency for each cell, we'll talk about what a cell is. What we're going to do is take the row total times the column total and divide by the table total for each one of those cells. That'll make more sense here in just a moment. All right, well, I think we're ready to go to example 2 now and see if we can make some sense out of this. Okay, so I'm looking at example 2 on page 604. Okay, and it says this: does the sample evidence suggest that one's happiness depends on one's marital status? We present the data in table 5 to answer this question. Use alpha equals 0.05 level of significance. So does the sample evidence suggest that one's happiness, and do you see that, depends on one's marital status? So we're asking if the two variables are independent or dependent. Okay, so we're going to assume H0, that the variables are independent. That there's one does not affect the probability of the other. Being married does not affect the probability of being happy. And then we'll have to find evidence for H1 that the variables are dependent. So we'd be finding evidence that one's marital status affects the probability of being happy or not. We're supposed to test this at alpha equals 0.05. And now we'll have to go get this test value. Chi-squared naught is equal to the summation of O sub I minus E sub I squared divided by E sub I. Okay, so here are steps 1, 2, and 3. We're going to table the rest of step 3 and steps 4 and 5 for a few moments. And we're going to go see how to figure this test value. And to do that, I want us to recreate table 10 at the top of page 604. So down the side, my row column is my row variable, I should say, is happiness. We have very happy, pretty happy, not too happy. Then across the top, our marital status will be our column variable, and that's married, widowed, divorced or separated, and never married. I don't know about you, but I know miserable people who are married and who aren't married and who are divorced and separated and who are never married. I know happy people in all four of those situations. But anyway, and so what happened was somebody went out and got some data. They asked this question: are you married, widowed, divorced, separated, or never married? And are you very happy, pretty happy, or not too happy? And they got this data. So they found 600 that were very happy and married, 720 that were pretty happy and married, and 93 that are not too happy and married. By the way, if you answer that not too happy and married, make sure that the other party is not around. That'd be bad if they heard that. So for widowed, the numbers were 63, 142, and 51. For divorced and separated, the numbers were 112, 355, and 119. And for never married were 144, 459, and 127. Okay. Now, what we have here then is a table, but in mathematics, what we call a rectangular array of numbers like this, see how we have a rectangular array of numbers? We have what? 3 rows and 4 columns. In mathematics, that's called a matrix. So effectively, we have a matrix here. Okay, and by the way, that's all the definition of a matrix is. If you've heard of matrix or if you've seen matrices in like an algebra class, it's just a rectangular array of numbers. That's the actual definition. Okay, now what we need to do, each one of these entries into the matrix, your book is referring to as a cell. So we have 12 cells here. These are the observed values in our 12 cells. Okay, now what we need are expected values for each one of those cells. Okay, so how do I find those? Well, remember what we said. We got to take the row total for each cell times the column total for each cell and divide it by the table total. So let's talk about how to find these values: row totals, column total, table total. Okay, so let's figure the row total for the first row. We'll just add right across. Well, Okay, get out your calculator and do that. 600 plus 63 plus 112 plus 144. That's 919. So there's our first row total. Let's do the next row. Yeah. 720 plus 142 plus 355 plus 459 is 1676. Okay, you guys complete those totals for the rows and then do each column as well. And we'll compare notes here in just a moment. Okay, who's got the not too happy row total? Peyton and Lauren, do you two have that? Give me a shout out.
I do.
Okay, what you got?
I have 390.
390 is what I got as well. Okay, Mackenzie and Rebecca. We'll throw in Bradley because Mackenzie has trouble with her audio. Do you have the column total for married?
Yeah, 1,413.
Good. And Jenna and Savannah, do you have the column total for widowed?
156.
That's what I got. Now, I don't have these last two, so I'm trusting you guys. So what's the total for divorce and separated? Anybody?
586.
586. And how about never married?
730.
Okay, thank you. All right, so we've got all our column totals. We've got all our row totals. Okay, now we need a table total. Well, that's all the numbers in the table added together. So you could get that by either adding these three numbers out here, which represented the totals of our rows, or add these four numbers down here. You should get the same number either way. So did you guys end up with 2,978 for the table total?
Hey, Mr. Black, I think that first row for very happy should be 919.
Okay, let me double check. You're right. Thank you. Does anybody else see any other mistakes here? Well, that means this number is wrong, too. So let me do that again. $2,985 now. Everybody golden? Okay, so now let's go and figure the expected values for each one of these cells. So I'm going to put that, your book puts that number in parentheses for each cell, okay? So for 600, the row total is 919, the column total is 1413, so I multiply those. and then I divide by the table total of 2985. $435.024. So maybe I should write that on here somewhere to show where that came from. That was 919 times 1413 divided by 2985. Okay, why don't you guys work on finishing the next 3 entries in that first row, just to practice a time or two. Okay, I hope you came up with these 3 numbers. 78.815, 180.413, and 224.747. Is that what you guys all got? Give me some reaction to that. Thumbs up, verbal, something. Okay, so I'm going to put those numbers in here. 78.815, 180.413, and 224.747. Okay, and then you would do these other 8 numbers in the same exact fashion. Okay, so I'm going to try to keep those separated. So you do these other 8 numbers in the same exact fashion. For this 720, you would take 1676 times 1413 and divide by 2985. Now, our book has done that for us. And this table is completed in table 11 on page 604. So let's write those numbers that were figured. Let's go ahead and write those back into our table. So for this one, it's 793.362. For this one, it's 143.737. 329.025. 409.876. I have to slide over here to get this one. 184.613. 33.447. 76.562. And 95.377. Now don't lose sight of what those numbers represent. They represent the numbers I would have expected to get in each cell if the variables were independent. Well, of course, we wouldn't have gotten the decimal. You can't have a decimal number of people, but right at that number of people is what we would expect. Okay, so we have observed values and we have expected values. Now, what does this formula say to do then? Take each observed value minus the expected value, square that, and divide by the expected value. Do that for all 12 of our pairs of numbers, and then add all those up. So in other words, for this first cell, I would take 600 minus 435.024, square that, so that's observed minus expected squared, and divide it by the expected value of 435.024. And it would have given me that number. I would do that for all 12 numbers and then add them up. Okay, your book did that at the bottom of the page. You see that? Here's the one I just did that I'm pointing at on the screen. Here's the next cell. Here's the third cell. And they say, da, 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 da. We did that for all the cells. Here's the next to last cell, and here's the very last cell. And when it did that for all 12, they got 224.166. 116, I should say. So that's your test value. Now, you're going, why didn't we do that? Because our calculator is going to figure that test value for us. So listen, all we're going to have to do is figure these expected values. Okay, so we have to have our observed values and we have to have expected values. We'll throw those into the calculator and it will figure our test value for us. Okay, you say, how's it going to do that? Well, I'm getting ready to show you how. What we have to do is enter these tables as matrices. So the menu for matrix is the second function of x to the negative 1. Here it's kind of a couple buttons over and up from your 7. See that? Second matrix. What we want to do is enter a matrix. And to enter a matrix, you always go to edit. So hit enter. And listen, it's going to ask for the size of your matrix. And it always goes rows first and then columns. Okay, well, we've got 1, 2, 3 rows and 1, 2, 3, 4 columns. Now listen, I used to get confused about the difference between a row and a column. And somebody said this, how do columns on a building run? Columns on a building look like this, don't they? So columns run vertically, rows run horizontally. That's how you know how many rows and columns you have. Okay, so the first matrix, I'm going to enter all the observed values. Okay, now I did that the other day. So this is a 3, enter, 4, enter matrix. And to enter your each entry, just punch the number in and hit enter, and it'll kick you over to the next one. Punch your next number in, hit enter, and it'll kick you over to the next one. And it'll keep doing that. So go ahead and enter all 12 of your entries as matrix A. And then give me a thumbs up to let me know that you're done. I have 3 thumbs up so far. There's 4, 5. Okay, I'm moving on here. Okay, now we got to enter our expected values in the same fashion. So go back to your matrix menu, go down, go over to edit again, and this time go down to 2, matrix B, and do the same thing. Hit enter, you have a 3x4 matrix, and enter the 12 entries of the expected values. And again, I did that the other day, so give me a thumbs up when you get that done. Okay, I've been watching my screen, so give me another thumbs up if you got that done. Okay, I'm seeing thumbs up, several thumbs ups. Okay, so now go back to your home screen, so second quit, and let's actually perform our test now. In stat test, this, remember I told you earlier there's a chi-squared test on here, but it's not the one we were doing before. It is this one. Okay, so it's the letter C, the chi-squared test. Okay, just hit enter. And all you got to do is tell your calculator where your observed matrix is and where your expected matrix is. So you need to know how to pull up matrix A. We'll go back to the matrix menu, its second matrix, and don't go over to edit. Just keep it on names and highlight A and hit enter, and it'll put it in there for you. Same thing, go down here to B, second matrix, go down to B, or just hit 2, and it'll throw matrix B in there for you. All right, and if we just calculate then, it's going to give us that chi-squared value that we saw in our book a while ago, 224.116. Okay, so now we're ready to go back up here and finish the test. Chi-squared naught is 224.116. If we were doing the p-value approach, look at p. P is 1.38 times 10 to the negative 45 power. Now listen, some of you put 1.38 e negative 45 on your test. I probably should have counted that wrong because I told you I would and then I didn't. Nobody knows what 1.38 e negative 45 means. It's 1.38 times 10 to the negative 45 power. That's P. which is way, way, way less than alpha. So we're going to reject H naught. Or if we were doing the classical approach, we'd have 0.05 in the right tail. Now, what about your degrees of freedom? Well, here's what you do. You take your number of rows minus 1 times your number of columns minus 1. So we had 3 rows minus 1 times we had 4 columns minus 1. So I'd take 2 times 3 here and get 6. So I'd use 6 degrees of freedom. Rows minus 1 times columns minus 1. If you need a formula there, it's R minus 1, C minus 1. Notice on your calculator it said 6 degrees of freedom. So if you go to your chi-squared chart and look under 6 degrees of freedom with 0.05 in the right tail, what you're going to find is 14.449 for our critical value. And certainly 224 is way in the shaded region, so we reject H naught. So there is sufficient evidence to show that the variables are dependent. In other words, there is sufficient evidence to show that one's level of happiness is dependent upon their marital status. Now, it doesn't say what, it doesn't say whether being unmarried makes you more happy or married makes you more happy or widowed or whatever. It doesn't say what causes what, it just says that they're not independent. That's the way the evidence is pointing, at least. Okay, by the way, I failed to mention earlier, I have posted the key to your test on Moodle. So if you want to go in there and check your work, you can. For this section, you need to make sure you know how to do problems like 4 and 9 to be ready for your final. So come with your questions from 12.1 and 12.2 on Monday. Now, I have one last question to ask you guys, and it's to help me for summer. So I want everybody to unmute, and I want to get a few responses here as we go. You guys all have your video off. I told you you don't have to have your video on. That's fine. I'm not griping at you. I'm thinking about, for summer, making a requirement that it be on. So what is it about having it on what gives you pause about having it on? I need a student's perspective here. And as soon as I get 3 or 4 responses here, we'll go.
I think it just takes some getting used to. Like at first it was a little uncomfortable, I guess. And it's also 8 o'clock in the morning, so I'm looking a little rough most of the time.
Okay. That's 1.
I agree with that.
That's 2. Come on, you're killing me here. Help me out. Help a brother out. I'm getting a
I
chat.
mean, I'm also doing it in my room, and I don't like showing off my room half the time because half the time it's nasty.
Okay, gotcha. That's 3. Give me one more. This is good feet. See, these are the things I need to hear from the student's perspective. I change locations a lot, have distractions in the background. Okay. Okay. That gives me a little bit to go on. So if you got any other thoughts on that, shoot me an email. So, hey, have a great weekend.
Thank you, too.
You as well.
You too.
Yeah, you too.